We are on the page 60. One more concept we are going to cover, which is in the intermediate algebra section 3.5, called functions. Okay, last concept we are going to cover in this class. So let's talk about what are functions. I'm going to double define it first. So functions have to be functional. Okay, something that have to work, right? Otherwise, why do we bother? So let's talk about concept first. What kind of things we call it function? You need this idea for all your algebra, pre-calculus, calculus. Okay, so you don't need this concept for your stats. And let's see. And simple way to put it, and if say I wanted to buy some turkeys, okay, I go to Safeway or I go to Rayleigh's. Okay, figure speech. So if over Safeway they say, okay, if 1 to 10 pounds of turkey, they are going to sell you for $10.99. Okay, the whole thing. Then if above 10 pounds, so go to 20 pounds, then they say, okay, we sell you for $16.99. All right. So if you hold this 12-pound turkey, how much do you think it would charge you? That will be $10.99, right? Obviously. So it's a simple. Would that work? Okay. However, just happen and say Rayleigh's, okay, 1 to 12 pounds, they say, okay, we charge you cheaper, say probably more expensive. They say $11.99. Then, however, somewhere they say, okay, above 10 pounds to 12 pounds, they charge you, say, $15.99. So for this 12-pound turkey, what do you think? How much you should pay? Say between 10, 20 pounds, they say $15.99. But you also saw, say, below 12 pounds, you say $11.99. So, which price you are going to pay for, right? So it's confusing when you go to a counter, then they have to call the manager, try to figure out. One person is fine, but if you have 2, 3, 4 customers doing the same thing, would that be confusing? We cannot do the business this way, right? So, does this one work? No, it will not work, right? Does this one work? Yes, obviously, right? What caused this confusion, right? Because one turkey, you can only have what? One price to sell, right? So to make it work, then we say, usually for math, we say we do from X to Y, right? So Y is your price range, say. X is your pound. How many pounds? So for each x, we can only have one price, right? So formally, how do? We say for each x, we can only have what? One y value, right? So to be able to work, we always do what? For math, from point A to point B, from point X to point Y, right? From X to Y, it has to have only one Y value to match with your X to be able to make it work. So that's the basic idea. For things we call function, then it has to be this way. From X to Y, for each X, you can only have one Y value. Okay, so let's see how we do it and math way to show what kind of things are functions. Okay, so concepts are this way, then the methods to show it. Okay, first one, we do it by mapping. Okay, so it's like if we have 1 pound, 2 pounds, 3 pounds of nuts. So 1 pound I sell for $2. 2 pounds I sell for $4. Then 3 pounds I sell for $6. Will that work? So you map your X to Y, right? Each one, individual one, you have individual price. So we are good. So, or we can show it by this way. Order the pairs, which you are familiar with, right? We did this. Order the pair 1 to 2 from X to Y, or 2 to 4, 3 to 6, right? Then we'll put a curly around it. Curly symbol is a formal math symbol, okay? It's a set. Put the things inside the basket, okay? It's the same thing as here. 1 to 2, 1 to 2, 2 to 4, 3 to 6, right? But in the ordered fashions and X and Y ordered pairs. We can do this way. Or we can do it this way by graphing, which you did, right? So we say, okay, say 1 to 2, 2 to 4, 3 to 6. If this way, then it is a function, okay? Or we may show it this way by the formulas, okay? Or by the equations. If I write y equals 2x, for each x, I only have one y as a result, right? For this one, for a line, which we did. So we can show it many, many ways. All right. So let's take a look. What kind of things are functions? What kind of things are not? Okay. So far we show you 4 different methods. Then let's check. Okay, different ways. So let's do the first one by mapping. So if I show you this way by mapping 1, 2, 3 to 2, 4, 6. If you do this way, 1 maps to 2, 2 maps to 2 as well, 3 maps to 4. What do you think? Is this a function? So you may say no, but actually is yes. Why? If I have, some old nuts, I want to sell either 1 pound or 2 pounds, or with $2. Can I do that? Right? Then 3 pounds, I sell for $4. Just like everything below 10 pounds of turkeys, 1, 2, 3, 4, all the way to 10 pounds, it's the same price. That's okay, right? Then if we do this way, if we do say 1, 2, 3, so I package that way, say $2 and $4, then 2 pounds I sell for $3, 3 pounds I sell for $8. Would that work? Not really. Why? Because all the 1 pound package, you may label it to $2 and $4. It's confusing, right? We probably don't want to do that unless you have, say, different size, different package for that. And for the outdated nuts, right? You can do that. But it's confusing. So you do the same problem, okay? You should only have one answer. Like this one problem, one answer. Second problem, you can have the same answer, but it's different problems. For the same problem, you should only have one answer in math world, right? We all have to get the same answers. We will not say, you do one answer, I do one. Subjectively, show your opinion. This is not English class, right? You can show your opinion. We don't do that in math. So, same kind of problem, you have to have just one answer. So we use mapping to show the functions, right? Second one, we use ordered pairs to show the function. In first one, I say I have 1 to 2, 2 to 2, 3 to 6. Is this a function? Yes. Just like that. 1 and 2 pair up, 2 and 2 pair up, 3 and 4 pair up. Right? If we have this one, 1 to 2, 1 to 4, and 2 to 6, 3 to 8. Do you think this is a function? No, because for the one same problem, you have two different answers. We don't do that. Okay, so that's not a function. So we use the mapping to show it. We used ordered pairs to show it. Then let's do some graphing and take a look if they are functions. So if I have this one, a line, positive slope, right? So for this x, what do I have? That's my y value. For this x, I have that y. For this x, I have that y, right? So this one is a function. Okay, then if I have this one, is this a function? Say here is 5. So 1 is 5, 2 is 5, 3 is 5. Is this function? Yes, because I can have a flat rate, right? Say, however many minutes, you use on your cell phone, I charge you $5 per month. We can do that, right? Then what kind of things are not functions? Take a look. If this one, okay, if here is what? Say 2 maps to 2, also 2 maps to what? -2. 2 to xy, 2, negative 2, xy. Would that be a function? For same x, you have what? 2 y values for this sideways parabola, right? It will not work. We will not call it function. So if we do a circle, would that be a function? No. Right? So for the graphing, and how do we check? You turn around for your page 60 on the sideway, it says vertical line test. Okay, so what do? You do the vertical line. If you meet the curve twice, then that's not, or 3 times, more than twice, then it's not a function. Okay, so we use a vertical line test to decide if the graph is a function or not. So those are functions. So if we have this one like this, what do you think? Vertical line test, right? Or we have the parabola. You are going to learn this in your 154A class like this. Is this a function? Yes. Okay, so if you have vertical line instead of horizontal line, is this a function? No. That means you have 2, you have 1, 3, 4, many values. So this one is not. Okay, so if you have this one, if you have 1 point here, 1 point here, 1 point here, same value, right? But the different y, so vertical line test, this one is not. So this one is yes, vertical line test. So that's how we use graphing, okay? When we use graphing to show, then we decide this curve is a function or not. Okay, so let's take a look if we use the formulas or equations, then see if it's a function or not, right? So let's take a look. Your page 61, y equals x. So when it's a equation, you cannot really tell. So what do you need to do? You need to graph it. Then use your vertical line test to do it, right? Y equals x. Remember how to graph your line? You use t-table, right? You can do that. Or you can use what? Y equals mx plus b to graph it, right? Rise over run. So you use a vertical line test. Is this a function? Yes. Okay. If your y equals 2x plus 1, we can just graph it. Then your y-intercept is what? 1, right? If we graph it with the slope-intercept form, then your slope is rise over run, 2 over 1. So you climb up 2 steps, run over 1, or you drop 2 steps, run this side over 1. So your line is this way. Is this a function? Yes. Right? So regularly slant line would be a function by the vertical line test. But how about special lines? We learn in not the slant line. Slant lines, you have both x and y there. But if you only have x or y, there will be what? Special cases. One is what? Not a slant line. One is a vertical line. One is what? Horizontal line. You have to remember which is which. So for y equals 5, then x is free rolling left and right, right? So x is 1, negative 1 would be what? Like this. Y is free rolling and up and down, right? So only x, that would be vertical line. Only y, that would be what? A horizontal line. Then we use a vertical line test. Is this a function? Yes. And for vertical line, is the function? No. Okay? So we described 4 different methods. Then we also checked if they are functions or not. We are going to talk about formally. Okay, how would we say it? If I ask you, what are functions? How would you describe? Formally, we use the second method. Okay? You would say a function is a set of what? Ordered pairs. It's from x to y, right? So we are talking about between x and y together. Then for each x value, we can only have what? Exactly 1 y values, right? That will be on your page 61. And those ordered pairs, we call them what? They are in a relation. How do you get from x to y? How do you get from point A to point B? Then we talk about how to relate x and y, right? When we write ordered pairs, it means talk about relation between x and y. Then x, we also call it domain. Domain means what? Your territory. Okay? Domain means what? All possible x values. Let's see, what do we mean by that? Okay, if I open a, meat shop, then I say, okay, I sell turkeys, I sell beef, I sell what? Tuna, fish. Then that would be my domain. Then I don't sell nuts, right? And I don't sell junk food there. So my domain would be what? All the meat, okay? So that would be my domain, means what? All the possible x values. Then y would be, we call it what? Range is all possible y values. That means like my price range. Okay, so range from and such price. So that would be my x maps to y. So we use those names, terminologies, referring back to the functions. Okay, so when we talk about functions, then whether or not the relation works for the from point A to point B, from x to y, it has to be what? They are ordered pairs for each x. You only have 1 y values. Then x, we call them domains. Y, we call them range. So if I ask you, what are functions? How would you answer it? You would say what? Just on your paper, first line. A function is a set of what? Ordered pairs that each x value only has exactly 1 y value. Okay? So if I write it this way, 1 to 5, and 2 to 10, and 3 to 15. Is this a function? Yes, right? Because for each x, you have individual y. Okay? So, then what's my domain? Domain would be all possible x values. So it would be what? 1, 2, 3. So you write individually, I have those. You put a curly there. Okay? What's my range? Price range will be what? 5, 10, and 15. Or you can use t-table you are familiar with. 1, 5, 2, 10, 3, 15. Right? Then that's your domain. That's your range. Okay, so we are talking about functions. Then with the name we use, domain and range. Okay, from x to y. So let's take a look, and we can use all of the pairs to show you, and sometimes we use different things to show you, right? We can use the graphs, we can use what? The equations. All right, let's look at your page 62 first. Let's do some graphing, okay, graphing style. Then look at the functions for its domain and range. All right, so for the first one, if we have this one from here to here, -3 and -2, to 5, 4. So we say domain is what? All possible x values. Range is all possible y values. So we are talking about this graph. Is this a function? Right? You use vertical line test. Then domain is all possible x values means what? How far you can go left and right. That's x, right? All the point on the line is what? X and y's, right? Then x means what? How far you can go from left to right. And range is what? How far you can go up and down, right? So what do you think? Up and right, left and right, from this point to here is what? -3 to 5. Then we write in interval notation is what? From -3 to 5. Then means what? Everything in between included. But we also include what? The endpoint. Endpoints, so we use bracket. Right? Then for the range, how far you can go up and down from here, right, to there. So it would be what? -2 to 4, right? So for interval notations, you always write a what? Smaller number to the what? Larger numbers. Either bracket or parentheses. You do that way. Right? Then look at the second one. If we have this one, okay, from here to there with arrow keys, what do you think? It will continue extend, right? So what's your domain? How far you can go left, how far you can go to the right on the point on the graph, right? X can go there, right? So it's what? -infinity to infinity. So for infinity symbols, you always use parentheses. Or you can write it this way, double line, is Greek character for R, right? All real numbers. This is a formal symbol of the math, and you can write it that way. Then what's your range? How far you can go up and down? For the Y, same thing, right? Then for your homework, I think you have those symbols you can use. I don't think you have that symbol to use, but sometimes we do that. Then if we have a line like this, going down from left to right, is this a function? What's your domain? Right? What's your range? All real numbers. If you have this one, if you have from here, -4 and 1, -1, right? Then you go here, then you go up, then you go there. Okay, go there. Then that's phi 2. Is this a function? Yes. What's your domain? How far you can go left and right? From here to there. That would be what? -4 to 5. Right? Then for your range, how far you can go up and down? So it would be what? -1 to 2. Is that right? How about this one? Next one. So if you have this way, okay, so like here is 3, 2. So how far you can go left and right? What do you think? Left and right is what? -infinity to infinity, right? What's your range? How far you can go up and down? Down you can go forever. How far you can go up? Only up to this point, right? So your range should be what? Write a smaller number, -infinity to what? 2. Is that right? So we are doing the concepts of domains and range for the functions. That's what we are doing, right? So we identify our domain and range. So if we have this way, here is -3, -4. What do you think? How far you can go left and right for your domain? -infinity to infinity. What's your range? How far you can go up and down? Up forever. Down is limited to -4, right? So we should write a smaller number, -4, all the way to infinity. Is that right? Okay, let's see. If we have this parabola, here is 2, 0. So what's your domain? Left and right. So it would be -infinity to infinity. All those points can keep going, right? Then range will be what? Not going below, but you can go up. From here, up, right? So from point 0, that's your y, right? Going up and down to infinity, right? And if we have upside down parabola, so if we have this way, -1 and 4, go forever, so, right? Then what's your domain? Left and right, forever, so -infinity to infinity. What's your range? Up and down, you can go down forever, but up is limited to here, right? So that would be negative infinity should be parentheses up to 4 with bracket, right? Then look at the next one. If we have this one, you start from -4 and 3, then you go down to -1, -1, right? Coming down here, then you go up again to 4 and 5. Okay, go up there. Then you come down here again to the 6 and -2. Okay, so what's your domain? Left and right. From here all the way to here. So from what? -4 all the way to where? 6. Right? And your range will be up and down, from down to here all the way up to there. Right? So that would be what? -2 and 5. Is this a function? Yes. Do your vertical line test. Okay, so number 10, if you have a special case, horizontal line. So what do you think your domain is? Left and right forever, right? Your range, just that point. That point is what? 2. So you only have 1 point for your range. Range doesn't go up and down, just stay at 2. So it's just a number 2. Then you use curly bracket to put it in there. Okay, is this a function? So we find the domain and range only for functions. Okay, so if we have this vertical line, is this a function? No, not a function. So we don't talk about domain and range anymore. Domain and range are only the concepts for what? Functions, right? That's what we are talking about. So we just reviewed all the graphs. If they are functions, then we find their domain and range. Okay? If we have the equations, then we have to decide their domain and range as well. What's the domain, right? It's hard for you to see domain and range unless you graph it. Then you know this graph is what? Negative y equals mx plus b, right? So m is a negative, so it's going down, -5. It's a 3, then you go down 1, 2, 3, 4, 5, and 1. So your graph looks like this. Is this a function? Yes. What's your domain? Domain will be -infinity to infinity. Okay? Then range will be what? Same thing. You can go up and down forever. So y equals 1 over x. It's hard for you to graph this. You don't know yet. We only graphed what? Linear equation. But for domain is what? All possible x value. If you plug in, you can find your y, right? So, but it's a fraction. That means what? You can put anything to the x. All real numbers except what? You cannot put there for fractions. Denominator cannot be 0. Okay? We are not going to talk about range for you in this class. You have to go, to the 154A to learn that. So you have to see the graph before you can tell what's your y. Okay? In 154 class, you can see, use calculator, you can graph it, use computer, you can graph it. Then you'll be able to tell. If we write 1 over x plus 4, what do you think is a fraction? So your domain is what? All real numbers, except which number you cannot use, which will make the denominator 0. What do you think? That would be what? -4, right? You will make a denominator 0, then you cannot use it. Okay, and let's see. If we have y equals absolute value of x plus 2. Okay, this one is a function. You cannot tell. You cannot see the graph until 154A class. So what do you think? Can x be positive? Can x be negative? Right? You can put a negative there. Then absolute value is result is a positive or 0. Can you put x is 0? Yes. So you can say all real numbers, or you can show it what? Like this. Right? You can do that. So we also identify the domains or range for the equations, right? Okay, then let's do one more thing. Here, we learn the new notations and for functions and the values. Okay, so if I write it this way, y equals 4x minus 1, I also write y equals x squared minus 5. So this one is a linear equation. This one is linear function. This one is quadratic function. You will learn this in 154A class when it goes to higher power, second power. Then you learn in pre-calculus, third power, fourth power, and higher, going higher and higher, right? As you know, as you go to the higher education. So, however, if I say, okay, x is 6, what's your y? Then you say, I have 2 y's here, then which one I'm going to use? It's not that clear, right? They both are functions. And you know this one, but you don't know this one yet. You will see it later, okay? But they both are functions. So you cannot tell how I'm going to, from point A to find the point B. So which one we should use when x is 6, then plug in to find the y, right? So what do? We differentiate them. How? Then both are functions. So I say this one is f. Okay, then I follow alphabetical order, F, G, H. So I use this one as G. Okay, then, but this f is the y which gets from x, so I say f of x. Then this one, I use g of x. Okay, so we use different symbols to make differentiate them so you can tell which one to use. Okay, so you are learning the new symbols for functions. We use this symbol, f of x or g of x. Then f of x actually is y, g of x actually means y. Okay, so if we ask you what is f of 6, what do we want you to do? It means what? Whatever inside is the x. X is 6. Then what is your y? That's what it means. Okay? So you need to plug in 6 to which function? First one or second one? Obvious now, f is first one, right? So you do 4 times 6 minus 1. So your y value is what? 25. Wait, 24. Never mind. 23, right? That's how we interpret the symbol. What do we need you to do? If we say, what is g of 2? What does that mean? It means your x is 2. What's your g? What's your y under this condition? So you plug in 2 to the x. 4 times 2 to the square minus 5. 2 square 4, 16 minus 5 is what? 11. So your y value for g function is 11. So your ordered pair is what? 2 to 11, right? Then this one ordered pair is what? 6 to 23. That's what we are talking about, the x and y. F and g functions show you the relation between x and y. The result is the y, the cos is the x. Okay, f half means what? Plug in here, 4 times half minus 1. That's 2. 2 minus 1 is what? 1. That's what we need you to do. Okay, so we are practicing the symbols for functions and to find the values. The inside is your x value. The f, the whole thing, is your y value. Okay, if g of -3, that would be plug in here, 4 to -3 to the square minus 5. That's 9. 36 minus 5 is what? 31. Okay, so in this section, we talk about what are functions. Means what? Each x pair, ordered pairs, right? Ordered pairs. Each x, you only have one y value. For each one problem, you can only have one result, right? Then we also show you 4 different ways to show a function. You can do what? By mapping, by ordered pairs, by graphing, or by the equation, right? Then we also talk about domain and range of a function. Domain is what? All possible x values. Range is all possible y values, right? Then we show you the graphs, how to see the domain and range. Then we also show you the new symbols for function, f and g. Then we also find the values this way, right? So that would be our intermediate algebra section 3.5 for functions.